this is part 3 of the Chapter 2 lecture notes. We are on slide number 36. Another way to represent the concentration of a mixture is molarity. And you'll see this in chemistry a lot. And it represents the number of moles of solute per liter of solvent. But to understand that, you have to understand what moles, the number of moles means. So 1 mole of a compound is equal to its molecular weight in grams. So if you were to go to the periodic table, for example, and look up the molecular weight for oxygen, it is 16. The atomic weight of oxygen is 16. The atomic weight of hydrogen is 1 point something, and carbon is 12 point something. So if you want to know the molecular weight, then you add all of those up. And if you have more than 1 atom of carbon, you would say like 12 times 6. And for hydrogen, you would say 1 times 12. And for oxygen, you would say 16 times 6. And that would give you 180 atomic mass units. So what that tells you is that if the molecular weight of glucose is 180.12, that means if you add 180.12 grams of glucose to enough water to make 1 liter of solution, then you would have a concentration of 1 capital M or 1 molar solution of glucose. I don't know that this is ever going to be something that, this is like a pretty complicated chemistry topic. So I'm going to move on, but at least we've gone over it. If you have any questions, you can ask if that turns out to be something that you have like quiz questions on or something. Okay, so we said solutions. Now colloids, which are also known as emulsions, they are heterogeneous mixtures, meaning that particles are not evenly distributed, but even though they're not evenly distributed, they don't settle out. And that gives the solution a cloudy or milky look, jello. And cytosol, by the way, cytosol, which is the fluid inside of our cells, is a colloid. And suspensions, blood would be a suspension. Okay, differences between mixtures and compounds. Unlike compounds, mixtures do not involve chemical bonding. If we want to separate a mixture, we can separate it by physical means. Like we can strain it or filter it, or even like for salt water, we could evaporate the water and the salt would be left behind. Those are physical ways to separate a substance. But if it's a compound, the only way to separate it, the different atoms in the compound, is by chemical means. Okay, so let's talk about chemical bonding. Chemical bonds are relationships, energy relationships between electrons of reacting atoms. And it is actually the electrons in the outermost electron shell that are going to be the ones involved in the chemical reaction. But let's talk about electron shells and let's talk about electrons a little bit. So each shell outside the nucleus contains electrons that have a certain amount of energy. So they're referred to also as energy levels. Electron shells can also be referred to as energy levels. An atom can have up to 7 electron shells. The first shell, which is closest to the nucleus, only can hold 2 electrons. The second shell can hold 8. And the third can hold a maximum of 18. And we don't have to go further than that in anatomy and physiology. But you do need to know the outermost electron shell is called the valence shell. And these are the ones, the valence electrons, the ones that are in the valence shell or the outermost electron shell. These are the ones involved in chemical reactions. So you do need to understand, just have an understanding of the octet rule or the rule of eights. Okay, atoms desire for their valence shell to be full, and for every energy level except energy level 1, the valence shell is full with 8 electrons. So if an atom is small, then the first shell can be the valence shell. It can be the outermost shell. And that first shell is full with 2 electrons, but it's the only exception. The rest of the valence shells are full with 8. So all atoms desire to have 8 electrons to be chemically stable. And so what they will do, unless they are in the group called the noble gases, they will gain, lose, or share electrons to achieve 8 electrons in their valence shell. Okay, so that's why chemical reactions happen, is in order to fill the valence shells of the atoms that are involved. And this is important. I'm going to put a star here if I can draw an asterisk anyway. If I can draw an asterisk for this last part, most atoms do not have full valence shells. Atoms will gain, lose, or share electrons with other atoms, and this causes a bond to form to achieve stability of 8 electrons in valence shell. Okay, so looking at these, helium is already stable because its outermost or valence shell electrons is the first energy level, and that first energy level can only hold 2 electrons, and it is full. So helium is stable. It's an example of an inert or noble gas. That means it doesn't react with other atoms. It doesn't need to form chemical bonds because it's already stable. Neon has 8 electrons in its second energy level, which is its valence shell because it's the outermost. And so neon is already stable. But when we look at these other atoms, they're not. Hydrogen has only 1 electron in its valence shell, which is the first energy level, so it needs 1 more because 2 would make it stable. Carbon has 1, 2, 3, 4 electrons in its valence shell, so it needs 4 more. Oxygen has 6, so it needs 2. And sodium has 1. So this is a different case because what it needs is 7, or it can lose this 1, and then its valence shell is now the second energy level, which already has 8 in it. Okay, so losing electrons is also an option. We're going to talk about the types of chemical bonds, and they are ionic, covalent, and hydrogen. We'll start with ionic bonds. Ionic bonds form between ions, and ions are atoms that have gained or lost electrons. And if they gain or lose electrons, they take on a charge, either a positive or a negative charge. And in this case, the number of protons does not equal the number of electrons. That only happens in atoms, neutral atoms that don't have a charge. Okay, so if an ion gains 1 or more electrons, it's going to become negatively charged, and we call it anion. We call it an anion. Okay, so that means it has a negative charge if it gains electrons, and that makes sense because what charge are the electrons? The electrons have a negative charge, right? So if you add electrons, you're going to get more of a negative charge. So the opposite is true if you remove or lose electrons. So an atom that loses an electron is called a cation because it takes on a positive charge. Because when it loses electrons, it doesn't lose protons. So it's lost a negative charge, meaning it has extra positive charge, and that gives it a positive charge. Okay? So losing an electron makes it positively charged or cation, and gaining an electron makes it an anion or negatively charged. And you've probably, hopefully, seen this example at least once, if not more, when we talk about ionic bonds. Almost always in science we use sodium and chlorine. So sodium isn't stable as an atom. Sodium has 1 electron in its valence shell, and chlorine is not stable as an atom. Chlorine has 7 electrons in its valence shell. 1, 2, 3, 4, 5, 6, 7. So what happens is the sodium transfers its electron to chlorine. And now you have sodium that has lost an electron and gained a positive charge. We call it a sodium ion, and this is how you write it, Na+. And then you have a chlorine atom which has gained an electron and taken on a negative charge, so we call it a chloride ion, and it's written this way, Cl-. And now that they're both oppositely charged, they're attracted to each other because opposite charges attract. And another thing is a salt doesn't have to be NaCl. That's the most common example of a salt, sodium chloride, table salt. But any ionic compounds, anytime that you have an ion, a positive ion and a negative ion that are attracted and form a compound, that's called a salt, unless it's an acid or a base. And those are the exceptions. Now, covalent bonds are formed for the same reason, but they're formed in a different way. Covalent bonds are formed by sharing valence shell electrons, okay? So if 2 electrons are shared, you have a single bond. That's 2 would be a pair of electrons. Then you have a single bond. 4 electrons or 2 pairs would be a double bond. 6 electrons or 3 pairs would be a triple bond. And then we have polar and nonpolar covalent bonds. So let's look at the formation of methane, which is a gas. It's got 1 carbon atom and 4 hydrogen atoms in it. This is going to be an example of a nonpolar covalent bond. So looking at the carbon atom, it has 4 valence electrons, so it needs to gain 4 in its valence shell. So it can do this by sharing with hydrogen, because if it shares one of its 4 valence electrons with a hydrogen, then that hydrogen becomes stable too. So it's like a mutually beneficial thing. Now you've got carbon sharing with 4 hydrogen atoms. Each hydrogen atom has 1, 2 valence electrons now that it shares, one of them with carbon, and then the carbon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So they're both, all five of these atoms are now stable. And this is a nonpolar covalent bond because they all have an equal pull on the electrons. There's not like a more negatively charged end or a more positively charged end of the molecule. Okay? Now, this is an example of oxygen gas, and this happens when each of the oxygen atoms needs 2 more electrons. They each have 6 in their valence shell. So if they get close, if they become close to each other in distance, and they each share 2 pairs of electrons, now all of these in this group belong to each of the atoms. So the oxygen on the left has, if we count them, 1, 2, 3, 4, 5, 6, 7, 8, when you count what it shares with the oxygen on the right. And then you do the same thing with the oxygen on the right. It also has 8 total electrons now. So you're going to draw the structural formula by putting 2 lines or a double bond between those oxygen atoms. The chemical formula is O2, and the structural formula is O double bond to O. And nitrogen is the same, it just forms a triple bond. So you've got 3 pairs that are shared here, and it forms a triple bond. The nitrogen gas in the air that we breathe is N2, that means 2 atoms of nitrogen, and it forms a triple bond